There are three key points to note about graphs and their inverses. To find the inverse, switch the values of x and y. A function and its inverse are symmetrical about the line y equals x, which looks like this. And to find the domain and range of the inverse, you simply switch the domain and range of the original function. Okay, so let's look at this discrete graph with random points. So the first thing we're going to do is draw the y equals x line. So you want to make sure that your line goes perfectly through. So it hits at 1, 1, 2, 2, 3, 3. Now it looks like my line's a little off. So let's adjust it. Should go through 1, 1, 2, 2, 3, 3. So here we go. Much better. Okay, so now what we're going to do is we're going to identify these points, and then we're going to switch the x and y and then plot the points of our inverse. So starting left to right, the farmost left point is -2, +2. So if we flipped it over the graph y equals x, then this means we're going to graph +2, -2. Okay, again, going left to right, our next point is -1, -3. So the inverse has the point -3, -1. Then we have 0, -2. So we're going to plot -2, 0. Our next orange dot or point in the original is 1, 5, so we're going to plot 5, 1, which is all the way out here. And then our last one is 3, -4, so we're going to do -4, +3. So those red dots are the inverse of our original function, which are represented by the orange dots. So now, if we go through and find the domain and range of the original, since this is not a continuous graph and they're just points, we're going to use the curly bracket for set notation. Our domain is -2, -1, 0, 1, and 3. Alright, so our range then are all the y values. 2, -3, -2, 5, and -4. Alright, so if we did the domain of our inverse, those values are 2, -3, -2, 5, and 4. And our range values of our inverse are going to be -2, -1, 0, 1, 3. Do you notice anything? Like I said originally, in the original function, our domain matches the range of our inverse, and the range of our original function matches the domain of our inverse. Okay, so now let's look at the function that has the equation y equals x squared. So we have a point at 0, 0, and we also have a point at 1, 1, and -1, 1. Then we have a point at 2, 4, and -2, 4. Okay, so now I wrote a chart for the original function. So now I'm going to switch all the x and y points, and I'm going to then plot those points and draw the graph of our inverse. So if I were to make an xy chart and switch all the x and y values, it will look like this. Okay, so now let's plot those points. Alright, so those are my plotted points. I'm going to connect them the best that I can to try to make a quadratic function. Alright, so if I drew in my y equals x, which is what our inverses are rotated over, does it look like it is symmetric about that line? Yes, it does. Okay, so the domain of our original function is all real numbers, and the domain of our range of our inverse, our orange graph, is all real numbers. Then the range of our original function in red is 0, including 0 to infinity, and the domain of our orange graph, our inverse, is also 0, including 0 to positive infinity. Now there's two more things that I want to talk about. The first is the vertical line test. That's a test that you should be familiar with. So the vertical line test states that if I were to draw a line through any part of any graph, it is a function if it only crosses at one point, which our original function, our quadratic, is a function. It passes the vertical line test. So let's see if our inverse, our orange graph here, is also a function. So if I drew a line through, it would cross not once but twice. So therefore, our inverse is not a function. There's one more test out there to be able to tell if the inverse is going to be a function or not, and that's a test you would do before you even graph the inverse. All you need is to look at the original. So the horizontal line test. If you complete the horizontal line test on the original function and it crosses it in more than one spot like this does, then you know that the inverse won't be a function. Or if it passes the horizontal line test for a different example, let's say, then you can say that the inverse will be a function.